Hello everyone. So I want to do this quick and easy. Don't want to take up too much time. So I'll get right down to it. But before we start, please remember my lab, especially on quizzes, when you start your quiz, not everyone will see the same questions on the same order. So the questions are shuffled. And not only the order is shuffled, but also the numbers within the questions. Like here you see 6.7%, or this 2600. Those numbers will pop up differently for everyone when you do your own quiz. So don't get fixated on the numbers. So that's why rather than I'll just give you tips about how to move forward with solutions and so on. So on this one, basically, the 2600 characters and this particular letter is used 6.7% of the time. So that's like your probability. So to find the mean for that, which is the first box here in part A, what you do is basically you multiply 6.7% with 2600. So I usually like using Excel as a scratch paper. So this is 2600 and this is 6.7, and you click on the percent. Actually it needs to be 6.7, and then here if you just multiply those two cells, so I'm using this as a scratch paper / calculator, it'll give you this number. And that would be, for those given rates and numbers, that would be my mean, which goes here. So again, that's not the answer for everyone. Keep that in mind because your numbers here would be different. And then the standard deviation. So there are different ways of finding standard deviation, but here you're given a total number of characters. And think of the 6.7% as the success rate, the probability, and then the failure rate would be 1 minus this probability. And the way you can do that is, I actually did that here on a different problem. So 2600 is your n, and 0.67, that's your success rate. That's P, and this is supposed to be 1 minus P, so I'm going to do, that's 1 minus 0.067, and the standard deviation would be actually, I don't know if you can see the formula here, it's N, the number of characters, times P, the success rate, times 1 minus P, the failure rate, and then you would take the square root of that, which would give you here. So that square root, 12.7, is the standard deviation for these numbers. So that's how you find the mean and the standard deviation. And then in part B, so this letter is occurring 177 times. Is this unusual? So the trick here is you look at your mean and this given number. If the given number is within 1 or 2 standard deviations of your mean, so our standard deviation was about 12 for this problem, and the mean was 174. So that's like a whole lot less than 1 standard deviation. So it's pretty close to the mean. So that means it's really not unusual. It's very, very usual. So you would say yes for this one. Not because it's below or greater. It's because it's within the range of usual values. So that's number 1. So this next question is about random variables, discrete, continuous, or maybe not a random variable. Just remember, it is continuous if it's something you can measure and it is discrete if it is something you can count. And if you can't measure or count, it's not a numerical value, then it's not random. So, and again, these A through F examples will be different in your quizzes. So the first one is number of people in a restaurant. So it's obviously, you can count it, which makes it discrete. The amount of rain, you can't really count that, but you can measure it, so that would be continuous. Eye color of people, so that's not really a number, it's a categorical variable which is not random. Time is always continuous, it's measurable. Number of light bulbs, number of free throw attempts, these are all countable, which makes them discrete. So focus on this next question here, which is you're getting a large shipment of tablets. You pick 28 randomly, and 5% is the rate of defects. So this is a simple probability question. So you would accept this if all 28 are non-defective, or if 27 are non-defective and 1 is defective. So you can, so here we can use the binomial formula to do that. Let me clean this up. So this is the probability of defective, probability of non-defective. So in scenario 1, you're gonna choose. So we're choosing 28 tablets. That means all 28 can be fine, which is this, first of all, combination of 28 0, so there's 0 defective, and you would multiply this with the probability, and since all 28 are going to be fine, this is to the 28th power exponents. And then here, in the second, that's the probability that you select 28 that all are fine. So that was scenario 1. In the other scenario, you can select 28 and only 1 can be defective, but the rest 27 are going to be fine. So here we need the combination of 28 out of 1 failure. And here you would multiply that with this success rate to the power 27 this time, multiplied by this to the power 1 basically. And then you would just add these up. So that would be your probability for this question, which is this one, the pharmaceutical. So here on the next one, you're drawing 7 cards out of a regular deck and no replacements. So you're recording the number of 4s. So is this a binomial experiment? Remember, in binomial experiments, the success and failure probabilities should be fixed. It shouldn't change at every trial. So when you draw a 4 and not replace it, or you draw a random card and not replace it, your probability of drawing a 4 in the next trial is changing. So that's why this is actually not a binomial, because the probability of success changes from one trial to the next. This next question should be fairly easy. P7, again, in your chart, you might have different values or a different number being asked, but P7, you basically look at your chart, find 7 or whatever that number is, and just copy the number underneath it into this box. That's the probability of 7. Exactly 7. And then in part B, probability of 7 or fewer Mexican Americans among 12. So that means 7 or fewer. So you're going to add all of these until 7. So the first few ones are already zeros. So you just 1, 2, 3, 4. These 4 numbers being added. But again, you're going to need to add all of them until 7, including 7. That's your box here under B. And then in C, which one is relevant for determining whether 7 is unusually low? So you need to look at the probability of 7 or fewer, not exactly 7. So that's why it will be B in this case. And then in D, you want to compare that to 0.05. If it's below that threshold, you'd say yes, it is unusually low. If it's above that, then you would say no. So in my case, the 0.07 is actually, sorry, P7 was actually 0.053, which is above, greater than 0.05. So it's not unusually low, so I would pick this one. Okay, so here let's focus on this number 6 on my screen. There was a very similar question to this, and it's solved the same way. There are slight differences. So here we're randomly selecting 24 for testing. So remember that, 24 selecting for testing. And we accept it if at most 2 tablets are defective. So 24, at most 2 defective, and the rate of defects is 2%. So going back to our screen here, so let me do this here. So again, our failure rate is 0.02, success rate is 0.98, and that's 1 minus this. Scenario 1, 24 good ones. Scenario 2, 23 good ones, 1 bad. And the last one is 22 good, 2 bad ones. These are 3 scenarios where we accept the whole shipment. So this, pay attention to the formula here. And these are the combination, actually I need to fix these. These are, use the combin, not the combina, because that turns a different number for this. And here there has been a mistake. That's, wait, that's supposed to be, yep. So yeah, it's fixed, and when you add these up, this is a different example. When you add these up here, that's the whole probability of accepting the entire shipment based on these scenarios. So in this next question, when N and P are given, it's really easy to calculate the mean, which is basically N times P. So you can just multiply those values and put it in this box. And the standard deviation would be the square root of N times P times 1 minus P. So multiply all 3 and take the square root. That's where the standard deviation is. And then this is simple. You have the mean and the standard deviation. Just subtract 2 standard deviations from the mean in this box, and then add 2 standard deviations to the mean, goes in this box. Very simple. So here you don't see the data table, but you'll see it in your own screen. Just remember, finding the probability of getting, so you basically pick that number from the data table and put it in here. And then the probability of getting 7 or more, you would add the numbers in the table that corresponds to 7 and more. And then determining 7 is an unusually high number, you look at the exactly 7. So that's part A for this one. And then the last piece, when you decide whether 7 is an unusually high number of P's within the pod, Um,